All right, we're going to talk about relations, functions. I'm going to throw a bunch of vocabulary at you here. First two terms, dependent and independent variables. So we have a table of values here. We're going to the airport. We're going to park for a while. And 0 to 1 hours is $5. 1 to 2 hours is $9. 2 to 3 hours, 11, and so on. You can see in the table. When you pull into a parking ramp, usually you see this kind of thing. Now the question here is, what depends on what? The charge depends on the time. So in this particular problem, the dependent variable is charge. The amount of money I have to pay is dependent on how long I stay. The independent variable would be time. Now, looking at it this way, 0 to 1 hours is 5, 1 to 2 hours is 9. This is not a very well organized charging schedule, because if I stay for exactly 1 hour, do I pay $5 or do I pay $9? Similarly, at 2 hours, do I pay $9 or do I pay 11? I'm going to want to pay 5. The parking garage is going to want me to pay 9. So let's make it a little better. Let's make it a little bit clearer. Let's separate out the dependent variable or the independent variable. When t is greater than 0 and less than or equal to 1, we're going to be charged $5. When t is greater than 1, so as soon as 1 hour passes, I'm paying $9. And notice on this graph, I have these steps. This is called a step function. And not including 0, but all the way up to 1 hour, I'm paying $5. As soon as I pass that 1 hour mark, I jump up to the $9 price. I pay that until 2 hours. And then I jump up to $11, and I pay that until the third hour hits. And then I jump up to $13. This open dot means we're excluding that. This point, 6, 18, right there, that open dot, is not part of this graph. The output for 6 is 13. We go up from 6, we see the included dot right there. Domain and range. Domain is the set of all inputs. Range is the set of outputs. Something that goes on forever, we can say that the domain or range might be all real numbers. For this problem, the domain, what is the smallest number that we will be charged money for? What is the shortest amount of time? The domain is going to be the set of all x's such that x is greater than 0, I don't want to include 0, but less than or equal to 24. The set of x's such that x is greater than 0 and x is less than or equal to 24. 0 is the smallest value at our graph, but we don't include it. And then our graph has values everywhere along here until we hit 24, then it's done. So that has to do with these numbers down here. The range. Now this one's going to be a little different because there are only certain values that are in our output that our dependent variable can have. The smallest value would be 5, 9, 11, 13, 18, 22, 28. The range in this case is just a list of numbers. It doesn't go on forever. It's not everything between 5 and 9. It could be 5, or it could be 9, or it could be 11. And it's just a discrete list of numbers, as opposed to a continuous interval like this. You really have to evaluate the graph and see what's going on. So here I have 4 different relations. A relation is any set of points which connects two variables. So these first two, we're given equations for. I have a relation that relates x and y equals x plus 3. This line represents all of those points. This sideways parabola represents all of the xy pairs that are related by this equation, x equals y squared. I could also be given just a region of values. This is a relation. Or simply a bunch of ordered pairs. Those are relations. A lot of times we talk about relations on the Cartesian coordinate system, xy ordered pairs, and the Cartesian coordinate system has 4 quadrants, starting at the top right and going anti-clockwise, or what most of us call counterclockwise. A function is a special type of relation. It's a relation in which no two ordered pairs have the same x-coordinate. Every input has exactly one output. And we'll look more at how to tell if a relation is a function in the next video.